End user programming is a vision of computing that allows people who are not professional software developers to program their own computers. So users of programs can customize or modify the programs that they use every day, or they can write their own to suit their own needs.
When there are new ways to think about programming computers, people can kind of effectively perform magic is the world that we're describing. I'm pretty excited for that.
Hey, this is Sri.
And this is Will.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead.
How's it going? I've missed you as much as people that don't see each other as much miss each other, but I guess that's a lot of people. This is season 2. Welcome to season 2.
Yeah, I mean, we have new mics. We probably sound a little better. I don't know if we look any better. We sound better.
Right. Like, we need to subscribe to moisturizer instead of like drinking whatever it is that we drink and getting new mics. But yeah, you can look forward to our viewers and listeners can look forward to a better sound this season, and perhaps better jokes and better self-referential themes. So yeah, that's what we got this season. What do we have to look forward this season from you?
So actually, last season I was drinking mostly alcoholic beverages, and now I've jumped on the health beverage wagon inspired by you, Will. And so that's my big change for season 2 is like I'm going to become a healthy person, drinking weird beverages from health food stores.
I see. The beer gut's going to turn into some 6-pack abs by the end of this season, I guess.
Yeah, exactly.
So here we go. All right. So what are we talking about this week in season 2, episode 1?
Well, hold on. What are we drinking this week?
Oh, right. What are we drinking this week? Yeah. I skipped too far into it. So what I'm drinking is the Waterloo Sparkling Water Mango flavor. You can see that without the reflection, I guess. And so, I don't know. Normally, I don't really like this flavored water, but this is what I got this week.
Cool. Well, so yeah, like I mentioned, I also made a little trip to Whole Foods, and I got this, I don't know if you can see, Poppy. Prebiotic orange soda. And so it's going to have a healthy gut and immunity sidekick. So yeah, hopefully this will combat all the damage that I've done in the previous season.
Yeah, maybe we get healthy colons this way. So to that, we know we have one single viewer that only tunes in every week to see what we're drinking. So cheers, Vic.
Cheers. Thanks for listening.
Cheers. So to then to backtrack on what we're talking about. What are we talking about this week? The anticipated reveal.
Yeah, so this week we are talking about end-user programming. So end-user programming is a vision of computing that allows people who are not professional software developers to program their own computers. So users of programs can customize or modify the programs that they use every day, or they can write their own to suit their own needs. So it's a kind of concept that allows the end users, who we typically think of as consumers, to also be creators in software development.
Yeah, we keep going back to old ideas in computing and software, but this is one of the early ones. When computers really first came out, it was only mainframe computers that were available for the military or like other government projects. And when computers shrunk and chips shrunk, like a lot of hobbyists got really excited because this meant a democratization of computing resources where you can create your own worlds and build your own software for people. And since then, we've been chasing it. And so I guess this week we're going to talk about where we are in like the past 4 decades. Well, we're not going to go through an entire history of it, but like where we are after chasing it for 40 years or so.
Yeah, definitely. So I think that all of the computing pioneers like Alan Kay and all the folks at Park and all of that were big proponents of kind of having the users be empowered by personal computing as opposed to sort of mainframe computing and business computing. And so a big component of that was end user programming. So the idea was that users could program their computers in friendly languages at that time. Programming was done in assembly. Even in environments like the Xerox PARC and their operating system, they started introducing more friendly programming environments like Logo and things that eventually morphed into AppleScript and a lot of scripting languages, which were kind of new at that time. And so, this has a huge storied history, and obviously, we can go take a walk down memory lane. But I think that what I'm really excited about is that it's kind of making a resurgence. So
in a different form, it's not quite recognizable if you haven't traced the lineage, but people are kind of trying to push in that direction.
Yeah, definitely. So, I think it'd be interesting to kind of touch upon some of the early attempts at end-user programming. And I think if I were to characterize it, there was a bit of a winter where it kind of fell by the wayside. And then talk a little bit about the interesting developments that are happening today that people might not immediately recognize as end-user programming. And then think about kind of the vision of the future as we tend to.
So what should we start with? Because there's many entry points into this topic. Yeah. Where should we start?
Yeah, so I think that what really got me interested in end-user programming was this really old program called Hypercard. So this predates me and my use of personal computers, but it's a phrase that you see quite frequently among really, really early personal computing users of I think the Mac, where basically Hypercard was a program that was a mix of a programming environment / wiki. So basically users would create these documents that could link to each other. So you'd have these documents called cards, and they can link to each other. They can contain images, they can contain buttons and sound. And so if you structured these cards just right, you can basically create a little navigable kind of user interface. And
it's almost like a flip book. That's why Hypercard used the metaphor of a card, so then they could then build upon that metaphor of a card to every program is a stack. So people could envision that cards are like pages, and if you want to flip through the stack, you could, and then the navigable buttons lets you pop cards on and off the stack and jump to the middle of a stack. So it was a programming metaphor that worked pretty well. And so I'm a little bit older than you, so I remember this in our grade school, middle school, something like that, like computer classes. And so plenty of kids were able to pick it up with a little bit of scripting and this stack metaphor to kind of build their own flip books and animation books and sometimes applications.
Wow, very cool. Okay, I didn't know that you had firsthand experience with Hypercard.
Oh, yeah. I mean, not too much. I didn't play around with it too much because I think at the time I had a PC. It wasn't really that into Macs, but there were plenty of kids in our school that took the computer class for it.
Cool. Yeah. So, I mean, the way that I envision it, it's kind of like a choose your own adventure kind of book, right? Like if you have this basically decision tree of cards, and you can kind of click around, and depending on your actions on the card leads you to one branch or the other. And so you can, in that sense, it's interactive and sort of programmable. And so, in my research about it, I think people look really fondly upon it as a empowering tool for creating fun games, as well as little utilities that people use to run their businesses. And I think that there was in some citation that was basically saying that Hypercard and its concepts could be credited as the kind of bringing hypertext to the masses and sort of popularizing this idea, and ultimately leading to the World Wide Web. So I don't know how true that is and how attributable it is to Hypercard, but you can kind of see the relation between kind of hypertext and Hypercard.
Well, I guess we'll have to ask Tim Berners-Lee whether he used Hypercard at all or not. But I think while he's credited for the internet and stuff, and hypertext actually, there's plenty of people that were probably in that era that kind of were influenced. I don't know if directly by Hypercard. In all my readings, I don't know that I made the connection, but I have read that statement before. So yeah, I guess in some sense, like Hypercard, the application itself was never actually networked because at the time it was written, network computing wasn't really that big of a thing. Like people were only maybe starting to get online, but not really. Like what was prevalent, Hypercard wasn't a network application, so it wasn't like you could connect to other Hypercard stacks, but you could definitely like link within your own. And I believe maybe you could open up the other Hyperstack cards. I wouldn't be surprised if you could.
Yeah. So I mean, I think I've read a ton about this programming environment or editor. And people really, really look fondly upon it. And I think the reason why is that it's a very prime example of end-user programming in that it doesn't look like programming that we do as professional software developers. But it is an environment and an authoring tool that lets the users of a program, like I was saying, people who we typically consider consumers, it empowers them to build something for themselves, either for fun or for actual productivity, in a way that we actually don't see all that commonly. Or we kind of see it today, like I alluded, but there was a period of time, maybe with the dominance of Windows, but at least in my experience using Windows from Windows 95 all the way until Windows 10, where there wasn't really that kind of tool that came in packaged with the operating system that kind of let you create something and run it on your own computer. There was this kind of two-class system. There were people who programmed computers, and then there were people who used the computers, and there was a big chasm between the two that you had to cross by learning magic incantations.
Yeah, definitely. Like people look on it fondly, and sometimes I wonder if they look back on it fondly because they were middle school back then, and like the things that shape us as adults tend to be what we were exposed to as middle schoolers, right? Because like definitely we notice a resurgence of a lot of retro gaming and retro console, that sort of thing. It's because like people that grew up in that age are now of age, and so are in positions of power, and nostalgia is a powerful drug to bring that sort of stuff back. But that aside, I think there is some amount of truth to the feeling of empowerment and creativity, and maybe that the Mac was just at the right time in the right place to sort of enable that. In the same way that I guess like Mac at the time enabled people to do a lot of like print design digitally, whereas they couldn't do that before, right? And so anytime that you take what was originally like the equivalent of a luxury good or something that only professionals were able to do, and you either like make it faster, cheaper, easier, then you bring it like to people that can create. It's, I guess, analogous to how Instagram makes it easy for anybody to look like they know what they're doing with the camera. And so in this way, Hypercard was the Instagram of its day. And so I guess like when you say like I don't see a lot of that today, I want to say it's probably in different forms, but I would largely agree with you in the sense that it's not front and center. It's not something that people immediately think of when they say, I want to use a computer. They're not using something that is like an end user programming thing. Besides the spreadsheet. So a spreadsheet is everywhere. That's my caveat. That's the biggest end user programming environment that we have today. But outside of that, I would say that it's not really prevalent. And then I guess another thing that I want to get to later on is maybe after all these years, we don't really know what programming looks like and like what it could be. And so that's why we don't recognize programming when we see it, or our view of programming is so narrow that we haven't really begun to explore the space of how to program computers until relatively recently.
That's a very, very intriguing foreshadowing. I look forward to when we get
right. Yeah. So let's put a pin in that and entice our audience to stay for a little bit longer so that our YouTube stats turn out to be better. So stick around. Yeah. So, anyways, what were you saying with the Hypercard, like with these things that I was mentioning?
Yeah, I mean, no, I think I'm really glad that you mentioned spreadsheets. So I want to pause a little bit from the examples of end user programming to kind of step back and talk about what we mean by end user programming and like what are some commonalities of the things that we're going to be talking about. So I found a really good essay from our friends at Ink and Switch, who we discussed when we were doing the local first programming. And so they sort of identified a couple of qualities of what makes programming environment kind of suitable for end users. And we can kind of talk about that as we go through some of these examples. And so the three qualities that they mentioned is one of embodiment, meaning that the thing that you see on the screen is a representation of the object that it represents. So
very meta sounding. So maybe a concrete example would help.
Yeah, I mean, I think if you've used a WYSIWYG editor, if you want to move something around in an editor like, I don't know, Dreamweaver, or that's a very old example, but
right,
basically,
exactly.
If you want to move an object around, you click that thing and you drag it around, and that moves it. Right? It's not that this object, an image, is represented by an image tag in HTML, and the way that you move it is by manipulating some other text or some other object. You directly interact with that object. And another example.
Right. And so to give some context, since like most people interact with WYSIWYGs nowadays, maybe we need to give the counterexample of how it used to be. Like how it used to be was that you just had straight up text. And in order to manipulate something or like change it, like you had to surround it with tags or something like that. And so you see this most often in HTML when you're editing the actual HTML code itself, or something like latex, which is usually still used today for laying out like scientific and academic papers. And so like WYSIWYG is where what you see is what you get. That's what the acronym stands for, for those of you that never looked it up. But then, like, if you manipulate that thing that you see, then you have a direct tactical relationship with it. Like, you can directly manipulate the objects rather than manipulating code that represents an object. So you're one step removed. And so this is what they're talking about with this first step, where the concept of embodiment.
Exactly. Yes. So that's embodiment. So you kind of have this direct connection with the objects that you are working with. The second one is that it's a living system. And so basically it means that when you update something, when you make some change, that is kind of updating on your screen in real time. So again, to draw a contrast, because a lot of software works that way today, if you program in a language, a compiled language like C or C++, the editing process is that you change some text, some source code, and then you run the compiler to tell it to compile, and it generates the program, and then you run the program again, and that's how you observe the behavior, the new behavior with your changes included. And so that could take a very long time. It can take seconds, minutes. Sometimes if you have a very bad build system, it can take even longer than that. And so this is in contrast to if you update a spreadsheet, you update a formula of a spreadsheet, or you update a cell of the spreadsheet, the changes kind of cascade instantly. And so that's what they mean by a living system. And it's a spectrum, right? Like obviously compared to punch cards, the C compiler is live. But relative to that, a Python shell is more live than that. But the end goal is that there is zero separation between your change and the effects of that change kind of happening on the screen. Right?
Yeah.
We're getting more and more to that point. Yeah.
Yeah. So beyond Python, like you have like spreadsheets, which things happen immediately, and so that's kind of the I guess like holy grail that we're shooting for here with end user programming. And
the last quality is that there's an in-place toolchain. And this one is, my take on this is that when you're programming in a traditional programming environment, we talk a lot about abstractions. And you need to have knowledge of a lot of abstractions in order to write a program. So when you're writing a program traditionally in software development, you tend to think about, you have your language, it has a standard library, you can pull in packages, NPM packages, and all of that stuff. You're aware of the operating system on which you're running and the services and interfaces it provides. So you kind of have to keep in your mind a lot of these separate systems and the abstractions that they offer. And so this is no good if you want an average person who doesn't live in this, is not immersed in this, to be able to program. And so InconSwitch says that a desirable quality of end-user programming environment is that your whole toolchain is in place. You don't have to kind of go somewhere. You don't have to keep in mind all of these other external things. You should be able to edit your program without having to install additional tools or programs or have knowledge of all these other things that surround the program that they're editing.
So by definition, like Emacs would be great. Well, because like people can have like shell out to in Emacs and have browsers in Emacs and whatnot. But obviously, like Emacs, yes. I don't know if does it fit the first two qualities. I mean, it's very
it is
immediate.
Actually, a live system.
Yeah, it is a live system. And what's the first one again?
Embodiment. So,
Embodiment. So it falls short there.
Yeah,
so maybe all we
there.
need to do is embody Emacs and we're good, right? Pat ourselves on the back and move forward.
Right. Clearly, Emacs is the holy grail. I mean, some people
might say so.
Yeah. But yeah. So I mean, I like these three qualities as a kind of structure for thinking about this, and I appreciate InconSwitch for laying the groundwork in their essay for kind of thinking about this, so I didn't have to think too hard. We can just jump in and record. But yeah, I mean, I think as we go through these, I want to think a little bit. And so we mentioned Hypercard, and I don't have firsthand experience, but certainly it seems like it is a GUI kind of WYSIWYG editor, so it has that embodiment principle.
Yeah.
Seems like it's live, and yeah, it's sort of self-contained. So I think that it ticks all three boxes.
Yeah.
And similarly, I think spreadsheets maybe have some of those properties as well.
Yeah, I think spreadsheets also have this sort of property. And I don't know, when you were going through this, I was just like, programmers could really, like I as a programmer would want these sort of things. But like, I guess the surface area for any new programming tool or tool chain is just so large that it's really tough to kind of cover all these unless it was built in from the very beginning, I guess. Yeah.
I do want to talk about this a little. I think that software developers are kind of masochists in that we put up with a lot of crap with our tools.
Also, it makes one wonder if it's like a status sort of thing, because like, compiled like language programmers are like, those interpreted programmer sort of things. And XKCD has a joke about this where like, the most alpha programmer is some programmer that is adjusting the metal on the platter of a disk as particles from the space or like, I don't know, whatever, to adjust that's how you program the ones and zeros on your computer. And so I guess in that sense it's like a status thing that makes us masochists.
Yeah, definitely. I mean, there's the phrase, I don't know if people use it anymore, but like script kiddies. So basically when all these scripting languages were coming out, the real programmers would deride all these new kids as script kiddies. They weren't doing real programming. They were just writing these like Perl scripts or Bash scripts or whatever it is what they were referring to. But
little did they know that Rails was coming, and so a lot of the web is now powered by scripting languages, at least on the application layer. Like that's not to say databases and anything are written in those languages, but
yeah. Well, I mean, we're welcome to Jamstack, where everything is written in JavaScript.
Exactly. Right.
And we refer to Jamstack so derisively.
Right. We do it ourselves, right? So, case in point.
Yeah. Yes. No, but I think, there is definitely a lot of status associated with that sort of masochism, how much pain you're willing to put up. But we've talked a lot about kind of the future of programming environments, whether that's Elm as well as Eve and many others, where they do actually have a lot of these qualities, right? Like, these are desirable qualities, not just for the uneducated masses. These are desirable qualities even for professionals who are writing this day in and day out. In fact, I would say even more so, because if you're doing this for a living and you have these properties, you can be maybe a 10x programmer, right? Just from the fact that you're not fighting your tools anymore.
I agree. Yeah, I do want. I mean, some of these ideas have made their way. I mean, the Invention principle, the talk by Brett Victor about like liveness and programming, really kind of opened a lot of programmers' eyes to the point where I think, I don't know, like Swift, I think borrows a lot of stuff from there as well. And so I think like new programming languages pull people ever so slightly in that direction once these sort of ideas have been popularized to the point where programmers that are making tools would put it into their new tools.
Yeah, you wouldn't think of web development today without kind of live reload, right? Like, it's sort of table stakes now. If you are doing web development, you expect those components to change immediately. And so I think I agree. They are filtering their way through. So going back to some examples, one that's really, really near and dear to my heart is Yahoo Pipes. Did you ever use that?
I did. I couldn't find any like great applications that I was like using it for, but I did play around with it to kind of get a couple things, because I think one of those things that I often dreamt about was that I could set up like an agent or robot in the cloud to do something for me. But I really do remember Yahoo Pipes, where it was one of the first kind of like workflow programming paradigms where you have nodes that do work and then you connect them together. Why was this near and dear to your heart? Were you in middle school at the time? And so that's why.
Actually, literally, that's why.
Oh, really? I was joking, but I guess that was true.
No, your thesis is proving correct. Yeah, so I was in middle school at this time, and I think that this was in the heyday of Web 2.0, and so I should explain what Yahoo Pipes was. It was a sort of basically a GUI where you build these data processing pipelines, and like you mentioned, the nodes are doing work, and you can feed this pipeline basically all kinds of events that are happening around the web. And so this was at a time when RSS feeds were a big thing, and so you could feed in RSS feeds from websites to kind of perform actions when websites updated or there was a new post or something. There was so you could watch like when a user uploaded a photo to Flickr, or did something on Delicious, or all those old Web 2.0 sites.
So like why did you find it so enticing?
So it again goes back to, I guess, that feeling of empowerment that is at the core, I think, of end user programming. So the whole ethos of Web 2.0 was that the web was kind of composable and user editable, and so every service exposed RSS feeds, tags, and kind of the early idea of APIs, right, where you could, as a user, post something to some URL. And so you could do interesting things with Yahoo Pipes, where if somebody posted a new picture to Flickr, you could like get a email alert, or if you followed like some food blog, you could take all the restaurants that were mentioned in the food blog and like map them on Yahoo Maps, and basically you could create these mashups. And I think they actually use that term in their documentation or something. But like basically you could mash up like source A and source B or source A and source B, and then combine them and output them onto a web page or a map or something else. And so it just seemed fun, because at that time, prior to Web 2.0, you basically just had these static web pages, and this was the first time where it felt like the internet was living, and I was a participant in this kind of living ecosystem.
I see. Yeah, so because outside of that was before you started program. I don't know if you were programming in middle school, but probably not very well.
GeoCities level.
I see. Yeah. It wasn't to the point where you could take this sort of stuff and put it together, but Yahoo Pipes got it within reach, and it had a philosophy and values behind it, so you felt like you were a participant rather than just a consumer. Huh. That's kind of interesting. Were there other technologies that was going to be along this line? Because I had another line of thought that we might have to put a pin in.
No, I mean we can go into it. The only thing I will mention is that Yahoo Pipes was killed due to the horrible mismanagement of Yahoo, and there's a very interesting Hacker News thread where all the alums of Yahoo Pipes kind of reminisce about it. But it lives on if you use tools like Zapier and IFT and all of those things. I think they're spiritual successors.
Oh,
they don't have that same feeling of freedom, but maybe that's just because I'm not in middle school anymore.
Right. The threshold in the bar for a 30-something odd programmer on the internet, optimistic at that, is much higher. Yeah, I mean, along those lines, I think the things that I was thinking about was why these things got killed off if they were so popular, right? Like Hypercard was pretty popular. I mean, it was bundled with the Mac, and according to the things that I've read, it just wasn't. It was like an economic backwater for Apple, so that's why they never really put a lot of investment in it. And I don't know about Yahoo. Was it the same for Yahoo Pipes? Do you know?
Yeah, pretty much. So at some point, Yahoo started to lose market share in their search engine, and then they pivoted to this portal model, and so all of their kind of pie in the sky non-revenue generating things were basically killed.
Yeah, so it makes me wonder if the heyday for end user programming applications is when a medium is relatively new, and the first wave of people are the people that can program, and so it's when the second wave wants to do what the first wave is doing, and you provide that tool, people can rapidly explore the design space for that thing and play it out. Because in the same way, when somebody finds a beachhead somewhere, then a whole bunch of people glom onto it because they want to finish exploring the space. It's why in 2012, the only startups that YC saw were Groupon clones, and a couple of years earlier, I think 2008 or 9, the only things that they saw were social media companies and stuff like that, right? And same thing with Uber. When was that? Maybe 2013-ish in their heyday. All people saw were Uber for this, Uber for that, right? Because people want to play out the space. Right. And so once people play out the space in something, then maybe they're okay, there's always going to be a long tail of applications for any particular platform. And so that's why Microsoft lets third-party developers do their thing and open it up. And then once the third-party developers figure out what's people actually really use, PowerPoint, word processors, spreadsheets, they'll just make a native version of that and everybody uses that. And then that stakes out the 80% of the use cases. And so do you think it's a matter of where people are on the adoption curve for a particular medium that end user programming makes a lot of sense, and when it doesn't, people feel it's played out, then you don't anymore? And so that's why Hypercard and Yahoo Pipes went away. But obviously spreadsheets are still around, and we consider it as part of this group, so maybe that's the combo breaker for this thing.
Yeah, I mean, I think there's something to that. Basically, I think my take on this is how long of a tail is the space of programs on that platform. And so there are a lot of very, very niche use cases for spreadsheets where it would be impossible for a spreadsheet software developer to kind of subsume all of the things and anticipate all of the things that people would want to do with spreadsheets and then just introduce that as a built-in functionality. And so I think that explains the longevity of spreadsheet.
But you could argue the same thing with like Yahoo Pipes, because like the web has so many things with, like lots of different APIs and services coming online all the time. So like, why did Yahoo Pipes die and spreadsheets didn't?
Yeah. Yeah, that's a good question. I mean, I actually don't know. I don't know how many things people wanted to mash up on the web. I think that the things that people wanted to mash up on the web got done. Like, I think...
Well, until you have a new service, then you would have like another N things with every additional thing. So I don't know. It's hard to say, right? Because like what we observe is what you're saying, but then in theory, you could have any number of mashups. But I guess the fact that Zapier exists is maybe a proof point. So maybe Yahoo just fucked it up, right?
Yeah, I think so. And I think it's interesting. Like Zapier basically pivoted to enterprise. So unlike IFT or IFTTT or whatever, however you want to pronounce it, where they stayed firmly in the consumer space. Zapier is all about like, you're an enterprise and you get like, some update to your CRM and then you trigger some email or something. And so I wonder if there is a lot more of this long tail customizability within enterprise versus the consumer, where there you can kind of anticipate their needs.
Yeah, I want to say that maybe that instinct makes a lot of sense, because also like Yahoo Pipes would have had to survive 10 years before enterprise would have opened itself to cloud software, right? And so maybe they were still a little too early. They just couldn't see that bridging the gap until 10 years later. They had to have survived for that long, and somebody running the show would have had the foresight to keep the lights on for that long in order for that stuff to play out. So yeah, maybe they were just really early.
Yeah, I think they were too early for their time. There was mismanagement, many reasons. I think the other thing is that it's just sort of a cultural shift where right after Web 2.0, I don't know if you would count, Facebook and Twitter as Web 2.0. They were kind of emerged from Web 2.0, but they kind of ushered in the kind of other age of like social web or whatever it is. And so the culture also shifted on the consumer side, where rather than giving users tools, like where the Web 2.0 ethos was all about users contributing to, shared knowledge, collectively tagging things, collectively, organizing things. We kind of shifted to this other model, maybe ad-driven model, maybe that's the economic engine behind it, where you're basically, the algorithm knows best, all right? And you are using something that is tuned by a centrally tuned algorithm. And so the kind of incentive structure to provide these interfaces to the user is gone, because like if I'm Facebook, I want to control that algorithm. I don't want to let users like do whatever, random stuff. And in fact, Facebook for a while, this wasn't end user programming, but like they were kind of open platform. Where people could like put apps up and have these like little quizzes and all of this stuff, and all of that just like went away.
Right, and throw sheep, and until they found that some developers really abuse that system. But yeah, exactly. And so that's not end user programming, but still, it kind of shows how
the openness of these platforms, gradually eroded.
we
definitely do the economics?
Was there ever a name for this like second era of Web 2.0? Because I've never actually come across it. Because like the children or the survivors of Web 2.0 certainly are a different beast than they were before. So I don't think there's a name to it, right?
You either die a hero or live long enough to see yourself become the villain, right?
Right, exactly. Yeah, no, I was just wondering if there was a name, because I haven't actually heard a name, but it was distinctly different than the original Web 2.0.
There's some shift. I think it was a very, very gradual shift, to the point where nobody could quite say, "Oh, we're in a different era now." But yeah, I think that actually I was thinking about something which is kind of tangentially related to both of these topics. So it's not quite programming, but it is a type of markup where, if you remember the really, really original Twitter, it didn't have any features. It was a horrible, like, minimalist, like, bare bones website.
Yeah.
Where it was basically an endless feed of things that people were SMSing to their number. But it allowed users, that kind of free form interface allowed users to come up with things like @tagging users by their handle, prefixing it with like the @ sign, as well as hashtags. Hashtags were not a feature that like a PM at Twitter planned. They were kind of organically invented. I think there was like some Web 2.0 conference or something where people were like, oh, like let's like, add these hashtags at the end of our posts so that like we can use the search function and like find each other's posts or something. And so it's not programming per se, but it is. I will say I'll stand behind the idea that it is a type of markup language that was collectively invented by this group for their own purposes, and then later Twitter was like, oh, this is a good idea, like let's actually just make this stuff part of our service.
Yeah, I would agree with that. There's a sense of it's a weird example of like collective end user programming, I guess. It's kind of like they dictated the thing and then it actually happened. Yeah, I guess I've often joked that Randall Munroe, he's like the world's most prolific programmer because all he has to do is draw a comic strip, and then there's like legions of programmers willing to make it happen. So in this sense, it's the other way around. There's like legions of users that like invent the hashtag because it suited their purposes, and then Twitter as a single entity is like, oh, I guess we'll implement this.
Yeah, and there was actually an interesting essay that I read about end user programming by this guy called Clay Shirky, who is like some kind of thought leader like on the internet.
Yeah, he's been around for a while.
Yeah. And so he has this essay called Situated Software, which is basically about end user programming, and specifically end user programming around groups. And so basically his thesis is that a group knows what they want out of a problem space, even more so than an individual. Like a group, let's say a team or a club or some social collective, can collectively develop some cultural knowledge about like their needs, what their community needs, and be able to encode that in software. And if you allow groups to be able to encode their the way that they run in software, that it's a lot more effective than having somebody kind of top down implement that. Yeah. So I mean, I think that it's an interesting idea. I think that. Yeah, I mean, I'll reiterate on this point. Like, there was a homogenization of what it means to be a consumer of computing. Like, it is the product of the economic engine that powered software for the last decade. Yeah. Right. So we kind of increased that distance. There was already that distance between the consumer and the programmer, and then we increased it even more because it was profitable to do so. And so, as we kind of go back away from that, I think things are going to get interesting. And we did touch upon this in one of these episodes that we talked about recently, where we were talking about the metaverse, like the kind of virtual environment, and how, again, it would be really boring to have a metaverse where you could only do the things that the developers of that metaverse allowed you to do, right? That's just a game. Like, this is just a big MMO. I think it'll get really more interesting when you as a user can modify that world in the same way that you as a living person in the world can do new things subject to the laws of physics, but like, you can do basically anything. And so
with consequences, of course, we also understand that there are rules and regulations, and so yeah.
yes. But yeah, I mean, I think so. I definitely think that end user programming will play a role in the metaverse, where people imbue objects with properties, programmable properties that the developers did not necessarily anticipate.
But I think you're right though. We'd probably have to get this right before like anybody else kind of sets some of these programming patterns into stone, because I can't imagine Meta or like Facebook wanting people to do this sort of thing. That doesn't seem in their DNA, right? And so like raising them to kind of establish the pattern for the metaverse is probably pretty important. So yeah, those of you listening out there that are working on this, especially followers of 6529, I think, Punk 6529, he talks about open metaverse a lot on Twitter. So
I think that looking at the reaction to Meta trying to capitalize on the metaverse concept and trying to basically become the central point of the metaverse, I think there was a lot of resistance to that within the Web3 community, and people were looking for open metaverse, and it might be for a variety of reasons. It might be for ideological reasons or financial reasons.
And
but I think
like move fast and broke things broke also user trust. So that they only have themselves to blame for that one. So
but I think that I don't think Facebook is going to all of a sudden, just because they changed their name, allow their metaverse to be all end user programmable. And I think that it's going to be really boring. I think that any metaverse that succeeds is going to have to introduce this at some point.
It's going to look more like or more like MySpace than Facebook is currently.
100%. Yeah.
So then going back to like end user programming, like we talked about like some of the examples of like why it existed and how it was killed off, and like the situated programming. So like one of the things I was wondering is like, why is it so hard to get end user programming right? Is it because programming is hard? Is it because we don't have the right abstractions or like way to think about programming computers that's hard? Or is it like I asked about like if it's an economic reason, right? And so I think we covered that a little bit. So I guess we can move to like, why is this so hard? Because we've been at it for a couple decades now.
Yeah, I think that we touched a little bit upon this on the data log episode, but basically there are ways to constrain programming so that it is not as hard or is not as intimidating.
Yeah.
But the problem is that eventually you run up against the wall and you're like, oh, I need to drop down into the lower level abstraction.
Yeah.
Like this thing is not, my problem is not suited for the abstractions that this environment is providing for me. At which point you're basically back into just regular programming, right? Like, if you think about the way that you build software using regular programming languages, what do you just build? It's weird. Like, you build software out of like things like loops and if and else and lists and dictionaries, and that's it, right? Like, every software that you've ever used, no matter how complex, is basically just cobbling together all these like four magical ingredients in a variety of ways.
I mean, programmers even before that would argue that like everything's a go-to. So I mean,
go-tos and registers.
Right.
So it depends on where you want to cut the abstraction, but like ultimately, like I think that's the distinction between end user programming and what we consider just standard programming, is that like end user programming provides a view of the world which is simplified and might work as long as your user's problem domain is well situated, sits squarely within the abstractions that you provide.
Right, but we have things like that for very narrow domains, such as like Photoshop for like photo editing. Like it works really well there. Like almost no like Photoshop users, like I need to drop down and write some script. Well, maybe like GIMP users, because can't you write like Python scripts with GIMP?
Yes.
But I mean, like so it makes me wonder like why there isn't like a more generalized modeling tool. Because I've heard Chris Granger talk about how programming is really an act of trying to model the problem domain that you're trying to solve, and like building the correct not only mental model for it, but like the abstraction around it. And so you would think that because this is what we do all the time, modeling, there would be like a set of elements and tools that are common to modeling as an activity, in the same way that there are common tools and elements to, say, drawing or writing. Because like we've been drawing and writing for a long time, and when I say writing, people won't necessarily think pen and paper, but like kind of we have letters and words and a language, and we have like some ways to like organize those things into paragraphs and pages, and then from there it could be like books, magazine, blah blah blah, and print. And so there's all these things. And then for drawing, like we think of, you know, at the very basic pen and paper, but then like we've abstracted out to like digital drawing, where there are like the pen tool, the paint tool, and ways to put layers and stuff like that. And so like you would think that there might be like common tools around modeling problems, but so far I haven't really seen really good ones. Besides, the spreadsheet is like the closest I can think of, and maybe Wolfram Alpha kind of, but like that most people aren't well versed there, and that's closer to regular programming. So at best, like I can only think of like spreadsheets, and I don't know why that is.
Yeah, I think you bring up a good point. Like, I think that there are formalisms in other fields, is what you're trying to get at, where you can kind of operate on them and you can compose them, and they behave in some way that we understand, right? Like, if you do this thing, like this thing will happen, and you can combine it with this other thing, and this thing will happen. And so, yeah, we are lacking that as a field, and one interesting line of thought that I've seen mentioned is that notation matters. Where imagine doing mathematics without Arabic numerals.
Yeah.
Right. Like you try to operate on these like Roman numerals. You're not going to do any kind of interesting math in your life. Like no matter how smart the Romans were, like they're not going to invent calculus using Roman numerals. Yeah,
and so I guess to build on that, it does remind me like a lot of the proofs that you see for like older proofs, like they weren't originally written that way. They were actually written in paragraphs with words. And so when you see the original, you're like, oh, this is completely unintelligible, because like people think that like math, like with the formulas, is like really dense and opaque, but like it's a far better improvement than what it used to be, when people would write like ambiguous paragraphs about what a proof is, or to kind of share a mathematical concept or an idea. I mean, that said, that's not to say that current mathematical notation can't be improved upon, because like in some fast moving or like edge fields in academia, you find people use completely different notations for the same idea, and people can't really agree on anything. And the further out you go, the fuzzier math notation gets. And so it's actually not quite as concrete as you might think of it as being, just by seeing the virtue of somebody using math notation. And it does remind me that recently I found out about projective geometric algebra. I think that's what it's called. And it's a way to replace a lot of the vector calculus that is prevalent in a lot of science and engineering, to the point where it simplifies things. Like, for example, like Maxwell's equations is usually represented as 4 equations, but using projective geometry, you can actually represent it as 1. You cheat a little, but yeah. So it's an example of like notation really helping things out, or even like rotations in 3D space. Like it's much more easily represented in projective geometry, and that's because like all the constraints of rotations is built into the notation itself, so that the person manipulating the rotations don't actually have to think about it. And so that's an example of where like the notation and tools really help you out.
Yeah, I am not smart enough to be casually reading about projective.
Neither am I, honestly,
or whatever. No, but I think that's a interesting observation. Yeah, I think that notation definitely plays a big role. I've heard people who think about programming language theory kind of espouse that idea, and I think that maybe we haven't found quite the right notation of programming, or to your point, the right notation for modeling problem spaces.
Yeah,
like we're just not there,
right? Because we have figured out like a couple good primitives that have stuck around, right? Like if statements. Yeah. I don't know. Actually, I've thought like maybe like we have many ways to represent if statements, actually. Like when you think of like polymorphism and like the strategy pattern and stuff like that, those are all like different ways of organizing an if statement, right? And or to deal with variations in the problem domain. Like how do we organize this code to deal with variation? I think that's where some of the complexity comes from. And so we do have like some of those basics like for loops and whatnot, but we haven't managed to, like, every time we go up one, like let's do object oriented programming, it sounds like it makes sense, but then like we eventually find like there's weaknesses here that like really entangle things and really ratchet up the complexity, that maybe this is not quite right. And so currently we have all these like branches of things where we're trying things out, and maybe
I think I'll echo that. I think we're at a local maximum, right? Like we know if statements are effective and for loops are effective, and to your point, like everybody has their own idea about like, okay, what's the next level on this ladder of abstraction? Functional programming has some ideas. Object-oriented programming has their own ideas. Yeah, but like, there's none that was like, oh, this is the smoking gun. This is the clear winner, right? Like, and so I think we're kind of fumbling around trying to find the clear winner. In our last episode we were talking about Eve, and I think they were hoping to find the jackpot of like, what is the beautiful abstraction that will unify like all the things, and their stab at it was data log and that kind of that thing. And I don't know, like maybe actually they failed due to economic reasons, not due to the failings of their technical notes. But but I agree. I think that it's not clear where to go from here, but it seems like everybody's like, there's somewhere else to go, because this can't be it.
And so I wonder if then the problem is because like abstraction is a tool of choice for programmers, but it really matters where you cut the abstraction in this interface. Like the thing that I often like to use as a metaphor is that abstraction is like the steering wheel of a car. Like without the abstraction, you have to time the firing of the pistons with the spark plug, and as a driver, like you don't want to do that. Or maybe the gas pedal, right? The gas pedal is what controls the spark plugs in a car. And so what you want is the gas pedal as an abstraction, right? Like you don't want to time the spark plugs. But like early cars, like the user interfaces for those are not what you would expect. Like the steering wheel for a car used to be like this horizontal crank. You've ever seen those? Yeah. So like we eventually figured out that wasn't quite right, and I expect it to be the same. And so I wonder if programming will always be hard, because like finding the right place to cut the interface for an abstraction is hard. And I don't know, maybe if we solve that problem, then it'll make it a lot easier to find the right abstraction more quickly. In the same way that like the guy that did the first man-powered flight over the English Channel, he solved the meta problem of how do we build a plane that after it crashes we can like reconstruct it in a matter of hours rather than days or weeks, so that we get more iterations. And so that's how he's solved the man-powered flight problem, was by solving the how do we reconstruct an airplane quickly problem. And so maybe if we solve the how do we like better figure out where to cut an interface problem for abstraction, that will find better abstractions more quickly.
Yeah, that's a really interesting avenue where, right now, we have a handful of abstractions that come out every once in a while. But yeah, maybe we just need to somehow have this Cambrian explosion of abstractions and different types of programming language. But here's a question I have for you, is that in this line of thinking, where if you we iterate collectively on abstractions and we find a magical abstraction for programming, do you think then that we don't need such a thing as end user programming, because that abstraction is so beautiful in its simplicity and its power and expressiveness that now anybody can understand it? Or do you think that there's a place for end user programming still?
Also, like, if we find the best abstraction, like, will we want to leverage it ourselves, or would we want to farm it out to professionals to do it in our stead?
Yeah, I mean, I guess what I'm asking is, so right now we have, regular programming, we have end user programming, and end user programming is like nice and comfy and fun, right?
Yeah.
And is that an artifact of the fact that like the real programming is difficult and tedious? Is that an artifact of the fact that like real programming hasn't yet quite found its abstraction, and then if it were to find the magic abstraction, then we don't need this dichotomy anymore, because now regular programming is just as fun.
Yeah. Maybe. I mean, it's hard for me to say, because of the fact that you mentioned before that sometimes you hire professionals because they need to drop down in the level of abstraction. And so if problems are always difficult enough with like weird enough edge cases, you're always going to want to have somebody that can drop a level down in abstraction to kind of help solve those problems that weren't anticipated. But I guess that's the thing that's supposed to be taken care of by the great abstraction. If we get the great unifying abstractor and you never have to drop down in abstraction, then maybe. I mean, maybe that's the equivalent of saying like all problems could be encapsulated, like all problems with edge cases, all the edge cases can be encapsulated by this abstraction, then, or set of abstractions, then I guess so. Like they should merge together into the same thing.
Yeah, so maybe, but it's. I can't imagine that we're supposed to be.
It's hard to imagine. It's hard to imagine. Yeah. Like it's like. We just don't have the notation or the tools or anything that's anything like that. So it can be hard to, I guess the closest that I can think of is maybe just like basic arithmetic that like encompasses so much of like the world that we don't really think about it anymore. But before that, even concepts like zero
it's like
or like negative numbers were like so hard for people to grasp. It was part of like knowledge of secret societies.
Right. We're basically like the Romans who are like asking each other, is there a better way to do numbers?
Are we the baddies?
Like, no. Yeah, exactly. Like, are we bad at math? And it's like, no, we are optimal at math.
Right, we're optimal
given what we know.
But we have these skulls on our helmets.
Yeah, exactly. So so going back, from these existential questions of whether we deserve, good software and whether we'll ever come upon it. Going back to that, so we mentioned at the top of the episode, right? I think that we are in this like golden age of, at least I think that we're in this golden age of end user programming, and there are reasons to be hopeful, right? Like, I think if you look at the slate of productivity tools that have come out recently, like Notion and Airtable and Roam Research, which we covered in episode 1 of season 1,
right?
Like, all of these are basically these live documents that expose, some amount of customizability, of interaction. They might allow some scripting, but even if they don't allow scripting, they allow end-user programming in much the sense that Hypercard allowed end-user programming because, it kind of through linking and that kind of thing.
Yeah, come to think of it, like
weave together.
Notion has the basic element and abstraction of blocks rather than cards, right? And so, like, I think the spirit of Hypercard lives on in a lot of these new products that you mentioned, like Airtable and Notion and Roam, but it's hidden. Like, unless you know the lineage, it's hard to draw that line. But
okay, that's where you're going with hidden. It's hidden in that you don't feel like you're programming,
right?
But it's not hidden in that, like, there are very, very lively communities of power users of these tools that are, blogging about and writing about and selling courses about and all manner of activity about, like, this is my Notion workflow, this is my Roam Research workflow, this is how I'm, like, organizing my novel in Roam, like, et cetera, all the different uses that one might have, all the long tail. People are kind of collectively bashing at these tools and, like, figuring out, like, okay, I can make this thing do this. Like, I can have, like, a calendar that, like, reminds me of this every, week or something.
Yeah.
Like, I see some of this, like, maybe it's due to the rise of this, like, prosumer, where these tools these days are actually introducing this end user programming. And it's kind of like, this phrase about AI where it's like, AI...
It's not AI anymore when it's so pervasive.
It's not AI anymore. Yeah, it's like once computer can do it, like, it's no longer AI. It's like, we're like, oh, well, we have these, like, talking pucks in our home that, like, can do, like, random stuff. And it's like, this is not AI. This is just, like, normal, like, stuff. And so similarly, it's not end user programming
when people,
once it exists.
Yeah, once it exists, because we don't call accountants programmers, but they use spreadsheets all day, right? Yeah, and get the computers to do stuff. Yeah, maybe. Although I want to say maybe the difference is that, like, Excel doesn't expose what we traditionally think of as a GUI or, like, a graphical user interface. Maybe like, if Excel lets you make something that looks like a web page or a web interface, then as part of the spreadsheet, then we might consider that more and more, right?
Well, so there are entire web pages that are powered by Airtable as a type of database. Like,
but then do they?
I don't know if that comes.
Like, well, how do they build the views? Are they pre-built views, or can you snap together components for that?
I don't think you can quite snap together components. Yeah, there might be some pre-built views. So in that sense, it's not fully programming.
But it's getting closer, definitely. Yeah. I hear what you're saying. Yeah, like Airtable is effectively like a souped-up spreadsheet / database that you can start to build familiar workflows around. I guess, like, the workflows are effectively programs and processes, right? Like, we just call it workflows, but they're really applications.
Yeah. Yeah, and I think we have the data storage, right? Like, so Airtable is basically you're basically creating a schema and you're making the storage decisions. We have these, like, workflow platforms like, Zapier. I think I mentioned iOS shortcuts very frequently on this podcast. So those things are there. I think what you mentioned is, I think, the that we're lacking kind of the interface building, right? Like if I have all this data stores and I can like run these like workflows on top of them, like that's great. Like the missing link is like, okay, how do I expose this data and like actually make like a view of it?
Yeah.
And like that's not quite there. Maybe Webflow.
Yeah, I was thinking like, why don't Webflow and Airtable try to like mash together and make some babies, so that
yeah, right.
you get like the best of both worlds or something like that. Maybe they're just two really disparate problems, but I've always imagined something like Excel where you can merge some of those cells together to make containers and be able to pop them out to make buttons or something like that. That seems entirely feasible as like a layout engine or something like that.
Right. Yeah, a layout engine. Yeah, it seems like all the pieces are there. I don't know.
Yeah, one of you listeners out there, make this your startup. So
yeah. Yes. So I think there are reasons to be optimistic, and I don't know. We kind of already went into the kind of deep philosophical effects of this thing, but yeah, like I don't know. Any other thoughts on like what are if we get this right and people are able to write their own programs yet again with the promise that was stolen from them for decades and they get it again, what will the world look like? Like, will it be substantially different for the user, for the software community?
Yeah, I mean, like, if it gets to a point where like it's one of the 3 R's, 4 R's, whatever, how many R's there are in education, like programming computers, like maybe not the way that we conceive of programming computers today, but like you're able to leverage it as a tool as much as kids nowadays leverage, I was going to say pencil and paper, but maybe like like the keyboard nowadays, keyboard and mouse. Like it's just kind of like one of the basics of being educated. And so what would that world look like? And so I guess people would be able to make their own applications, if not agents, in computers as they have their ideas. And they wouldn't need they wouldn't need to hire somebody to do it. It's kind of like nowadays, like it's almost kind of like in the 1200s, if somebody wants to like write something down, they need to go hire like a scribe or something. I don't know if they actually did that, but it's
right.
it's the equivalent of that. So then it would be a world in which programming doesn't look like what it does today. Programming would just be where you would be able to get the computer to do whatever it is that you would need it to do. And two, anybody who is considered educated would know how to do it, just as nowadays anybody who is considered educated can read words on a page and be able to write by themselves. Of course, there'll be like professional writers that you can hire, just like there are professional writers today. But for the most part, like people know how to make their own to-do list on pen and paper, like either or like type it on a keyboard. Like nobody like contracts it out. Like I need to make a to-do list. Let's hire somebody. Like get on Fiverr for that. And so, what would that world look like? And I guess you would still have a professional class of programmers, but then the type of things that you would hire professional for tends to be more polished, and definitely for economic reasons because the stakes are higher. But for things that are like everyday, like throwaway sort of stuff, like you would just do it yourself. You know, like you might watch a couple YouTube videos, right? Just like their home, like YouTube videos on like how to, I don't know, like write,
change a tire.
Yeah, change a tire, or like with respect to writing, like how to write your resume. The basic things that are kind of one-off, you would just be able to use your computer to do it. And I imagine it'd just be a lot more fluid. And I think it would just fade into the background, honestly. Like people wouldn't think of it as a thing. It would be just like, but of course, like who wouldn't be able to do that sort of thing? Or it's just expected to the point where like using computer to get something to do that nobody thought of doing before is just considered something that you do naturally. So like if, for example, in our podcast here, like we wanted it to, I don't know, like we need some makeup. or something, some sort of filter.
Yeah.
And we just thought of a
Right.
filter that we wanted. We'd be able to just tell the computer, hey, this is how you do it. And then we would be able to get it, and then it would integrate with whatever software that we're using. And so I guess like the more I talk about this, the more it seems like, oh, this sounds really familiar. Like people were talking about this decades ago, like with interoperability of software and stuff like that. But I don't know if like the economic incentives of like software companies and how the business of software would make that happen. So yeah, I don't know.
Yeah. I'm fully on board with this vision, except I object to the word computer.
Well, let's shut down the press and step off this podcast, because what are we doing?
I'm opposed to computers. No, I think that when we use the word computer, I think it's so wed to, computing devices as we think of them
Today,
right now, today. Like, they have these applications, they have these GUIs, et cetera, et cetera. I'm really, really interested in computing being a component of a metaverse where your computing environment is not a 2D world. It's a 3D world that you live in, that you own objects in, whatever, right? You have property in there and whatever. And what you want to really do is you want to give these things special properties. Maybe you have like some secret area, like, and you want like to prevent people who don't own the right like NFT to like come there. And so you need like a bouncer, and like you need to like program this bouncer to like who does these things. And like, so programming is going to look like, oh, I need this thing in this like world, and I'm going to somehow like give this thing these special properties that are based in logic or conditions or whatever it is. And I think that that's the substrate that people are going to be programming. They're not going to be really programming like apps and like things like this. Like, I think for the most part, people don't seem too interested in programming apps. But they might be interested in programming games.
I think that steps out even farther, because like I was going to say, like what you're talking about is computing not embodied in a device, but like the key word there is environment, like computing as an environment, right? So like it's a strange concept, but it's kind of like where the room is the computer, or like the house that you're in is the computer. And so like anything that you see, touch, or can manipulate, you can program. And that means that you can get it to change its behavior based on inputs and perhaps some sort of hidden state. And so right now, like the atoms that we have in the so-called real world, they're not exactly programmable, because we can't really envision like what you would do with some of it. Maybe some of it. Like as I'm looking around the house, obviously like shutters can open and close, doors can open and close.
Yeah, there's a whole IoT and all that. I think that's kind of getting to that.
Right, but even beyond that, I guess like in the metaverse, like because everything is a digital object, like the possibility explode for things that you normally wouldn't think of as programmable, such as like wallpaper or like even like the size of the room and stuff like that.
Right.
And
like, I want a house in which like when there are more than like 5 people in there, or more than some amount of people, it expands.
Yeah, give me a ballroom when I'm having a party or something like that. So so there's stuff like that. And so when you are in there, I think the concept of embodiment then it becomes really important. And so this does bring me back to something that I forgot to mention when we were talking about embodiment. There is a game called Autonauts, like automatic astronauts, I guess, Autonauts. The reason why Autonauts really worked as a game about programming is because the way that you program the robots in Autonauts is that you tell the robot in the game, watch me, and then you do the actions that you want the robot to do, and as you're doing them, you can see it observing you and writing the program out. And The program looks like a Scratch program. If you've ever seen like the Scratch programming language for kids, with the blocks and stuff. So basically it generates these blocks as it's watching you do things. And so you can rearrange those things afterwards, but like the barrier to entry is pretty low because there's this concept of embodiment in which you just do the things that you have in real life, and then the agent is able to kind of copy you. And so going back to your Metaverse example, maybe like programming as something that any educated person does is part of a programming environment, like programming as an environment, is that you're able to say to some agent whether they have a body like in the metaverse or not. You can just say like, do these things, watch me, and then you go and do those things, but you don't have to like be perfect in doing it because you can always re-edit it afterwards after that. And so maybe that's one way where it becomes a way for people to program, and then the idea of abstraction would come after that, where you're able to like package these up in reusable forms in other ways.
Yeah, I think if you go back to the ink and switch principles for end user programming, certainly the metaverse has the properties of embodiment and it has the property of liveness. In terms of whether you can have a self-contained abstraction or not, yeah, I think in the example that you provide where you are teaching by example, you don't have to drop into a different language or use some library or something. I think that's powerful. I think that increasingly people are interacting with machine learning models through in a similar way, through prompt engineering. Basically you feed like GPT-3 like a bunch of examples, and then like it tries to do the thing that you're trying to teach it to do. And so if we get to the point where we have these models that we can just basically prompt engineer, right? So you say, watch me do this thing a couple times.
Because the trouble I always had with embodiment is that the logic, like I'm not sure exactly how to represent logic in the world itself. Like it almost always seems like a separate panel that you have to show if you don't teach by example. So if you've ever seen those like markup editors, like outside of Typora, which is like a what you see is what you get sort of markup editor, you always see like one side is the view, right, and then the other side is the actual code that you're writing. And so when the problem is even more pronounced when you're adding extra logic to things that have like a surface view, because like you don't necessarily want to expose all that. And so I think there's probably UI ways to kind of figure this out. Maybe it explodes, or maybe like every object is a card where you flip it and the backside is the program or something like that. But I think that is one of those UX challenges that we haven't really figured out when it comes to embodied programming.
Yeah, so I think so maybe that's my thesis. If I were to place bets, I think that's where things are going to happen. There's the flip side actually, right? So we mentioned in previous podcasts about a dynamic land, and like they had a computing environment, which is an actual physical computing environment, but similarly trying to give atoms basically some amount of programmability and manipulability. Yeah. And so that's also an interesting project.
Dynamic Land was able to bring this concept of like programming as an environment to a real room rather than having to rely on VR and Metaverse to exist. So it's pretty interesting. We might have to talk more about it in a later episode.
Yeah. So all in all, I think my take to summarize, I think you know in Harry Potter.
Like,
You wonder like all this, like every object is just like brimming with like functionality, right? Like everything is doing all kinds of stuff, and I always wondered like, how is this stuff getting made? Like somebody had to make the like photos with that move and talk back to you. Like it's not like a given that will exist. Like there must be a way that these people are creating these things and imbuing these objects with this magic, and it might look kind of like programming. Like, I don't know what kind of magic programming.
Right, because Harry Potter never really described like how spells were invented or like how they do in production. Like, are there like a special wizard school or like special class of wizards that devote explicitly to the study of creating new magic spells? Like, we don't know.
Yeah, right. Like, are there the program? And then like you create a new magic spell and then like you push it and it's like available to everybody's wand. Like, is it like an NPM package?
Yeah. Because it exists in the environment, or like do you have to pay for that with like because it's a subscription, right? Like, you have subscription spells, and so maybe like after the subscription is gone, your spell no longer works. Like, how does that exactly work? I'm not really sure.
Don't bring our corrupt like capitalistic models of software development to magic.
Right. But no, I think that's probably a good way to put it, because like it's kind of hard to imagine when we think about it from a programming point of view, because like as much as we try to imbue the things around us with programming, like things are always like half broken. Jonathan Blow is a game programmer mentioned before, and he has this talk called The End of Civilization, because like programming has just gotten too complex. One of the exercises he tried to do was just to write down every time a piece of software was broken. And so he had to stop after a week because there's just too many of them for him to write down. And then it like in the night before he had to give the talk, like at the hotel, he had this weird bug in which when the phone rang, the thermostat also beeped, and he was able to reproduce it like consistently. He has no idea why, right? It's some weird coupling. And so like I always thought that like if our world was imbued with magic, like in Harry Potter, you'd have these weird couplings of states that would be infuriating. But she doesn't really write about that, right? So it seems like people are usually in control of their magic in that world, at least for the most part, I think. But like,
I think, you're right. I think but honestly, if we take our current incentive structure and our current understanding of programming and modeling, and you suddenly imbue everything with that, like, it's going to be a mess. So maybe we should like figure our shit out before making everything magic.
Yeah. Well, I mean, we'll see. But did the inventors of the combustible engine say, well, let's figure out climate change before we unleash this? And so here we are today, right? So I don't know. I don't know what to say, because then there would be no Uber Eats and I would have starved tonight or whatever. So,
all right, fair enough. I think, if we get to the point where, we're all living in the metaverse and everything is programmable and magic, but there are bugs, we will
have to live with it.
Right.
We'll have to live with it in some way. So with that, how's your optimism?
I'm super stoked to shed my physical existence and live in a metaverse where I can tell my house to become bigger or whenever I want.
Right, all ready to strip your corporeal suit, for the metaverse. Yeah, I think I'm generally pretty excited when there are new ways to think about programming computers, because I guess I don't know if people have already picked up on it or not. I'm a little bit of a programming language nerd, but I think the world in which people can kind of effectively perform magic is the world that we're describing. I'm pretty excited for that. Yeah. So with that, I am not even in this world. I am in the world of Harry Potter now, I guess.
Yes, that's a new one for this season.
Right.
So, maybe we're gonna launch to different places than just
exactly.
Cool. Well, with that, I think we are thoroughly optimistic
and out of time. So, right, optimistic and out of time.
We're out of time. We're out of time. So anyway, I'm Sri.
And this is Will.
And this has been the Technium. Come back next time for more ramblings about the metaverse and self-reference and a little bit of technology.
Right. Exactly. Shalaka subscribe, or was it subscribe, like, and punch that ring bell, whatever it is. Take care, and we will see you next week. All right. Bye-bye.